Let's go over the learning goals. Some of you seem to like the learning goals, so we'll just quickly mention them. We're going to understand the meaning of absolute extrema, something we kind of talked a little bit about in the first advanced functions course, but couldn't really come up with the tools to find where these extremes were. All right. And then we're going to learn the algorithm for finding the extremes of a function on an interval. So there's always going to be a domain for these questions. I'm only going to be asking you for the extreme between defined limits. So is it going to be from 1 to 10 or from -6 to 8 or whatever? There is always going to be a defined limited domain over which we're going to find where this extreme is. And yeah, for now, right, we're not going to get into whether the extreme is a max or a, well, we are going to get into whether it's a max or a min, but we don't have all the precise tools for that yet. We'll get to that. All right, absolute max and min. So if a function is defined and differentiable on an interval going from a to b, the absolute max refers to the greatest y value of the function on that interval. The minimum, of course, refers to the least y value of that interval. So if I give you an equation and say, what is the smallest number, meaning the y value between the a and the b, you're going to be able to tell me what that is, all right, with the steps that we're going to go through right now. So those of you who have done some programming know the word algorithm. Algorithm is just a series of steps. That's all it is, right? It's just instructions that you give a computer, and the computer just carries out those steps. So the algorithm for determining what the maximum is, or the extremes are, or the minimum or maximum, I should say, extremes are, is to determine the derivative of the function, because you're going to need the derivative. Find the values where the derivative is 0. Where is the horizontal tangent? Because that's likely a candidate for where that max or that min is. Check if any of these are within the specified domain of the function. So are these points where the function has a horizontal tangent within the restricted domain that we have set for searching for this extreme? Because if it isn't, then we have to discard it. We can't use it. Evaluate the function at each endpoint of the specified domain. So maybe your max or your min is actually on the boundary. So, you may not have to actually pick a point that's inside of the boundary if the boundary itself is the max or the min. That's possible. The absolute max or min values of the function will be apparent from the results of step 4. Okay? So we're going to go through all of these steps, and then at the end of this, we're going to have an answer. That's the basic premise of what we're going to do today. Here is the first example. Function, cubic function, x cubed minus 2x squared, 2.5x squared minus 2x plus 4. And we're looking between -1 and 4. So we've already said that anything outside of -1 to 4, we're not going to consider. And look, notice that these are square brackets. That's important. We're saying that -1 or 4 are included in our search. And that's why we have to test those actual values as well to see if those could be the answer, because it is possible that the boundaries are the answer. Okay. So let's just keep going here. Since the function is cubic, I'd expect the curve has 2 turning points. We've talked about turning points before, or maybe not in this course, maybe in the advanced functions course. One could be a local max, the other could be a local min. And these points would lie on the curve where the tangents are horizontal. So if there's a max or a min, then you will have a horizontal tangent there. And of course, the derivative is what we're going to use to find that. So let's go back and look at the function again. That's the function right there. And we know that we can derive that easily enough. So we're past the stage where I need to teach you that anymore. There's a first derivative, 3x squared minus 5x minus 2. All right, compare that to the original function. And again, I don't need to teach you how to factor. These would be the factors. And then, of course, we can, because we're now taking the derivative and setting it equal to 0, we know we have 2 horizontal tangents, and that's because we're setting each of these equal to 0. So here are the 2 horizontal tangents at 0, at x equals -1/3 and at x equals 2. That's where your horizontal tangents are. So based on the algorithm, we now have to test 4 points to see where the maxes and mins are. Let me tell you what the points are that we have to test. We have to find the f of the minus 1/3, the f of the 2, the f of the, let me tell you again, there's a boundary, -1 to 4. F of -1 and the f of 4. Let me just say we have to find the f of the 2 points, -1/3, 2, -1. And why -1? Because that's the domain that we're working with. And the last one, of course, is the f of 4. Now, one of the things we have to establish and make sure we're okay with is that these points that we chose, that we not chose, but that made the function, the derivative equal to 0, these points are within the domain of -1 to 4, and clearly they are. -1/3 and 2 are between -1 and 4. So that means that we're good there. So this is now the tedious process that we have to go through. Now, if you have a calculator like like mine, like the Casio calculator, then it's not that hard, right? Because you can just simply keep changing a number and evaluate for each number. So I'm going to grab my Casio, and hopefully you're going to do the same thing as well. My Casio, and I'm not touting Casio as being the only calculator to have. There are several good calculators out there. And by the way, we're not testing this out in the derivative. We're testing it out in the original function. That's where we're going with this. So I'm going to put that function into my calculator right now. So let's see now, x, and you should be doing the same thing as well, to the power of 3 minus 2.5 x squared minus 2x plus 4. Okay, so I have the function in my calculator. So I'm going to find the f, and you can use your calculator as well, -1/3. If you get a different answer from me, please let me know. So I'm going to put in the -1/3 now, -1/3. I'm getting 235/54, which of course we should turn into a decimal so that we can easily compare it from one to the other. Everybody else got the same thing I just got? Works out to be 4.35. Let's say 4.4. Yeah, it is a little tedious. Let me admit that. But can you all try that on your calculator? Just confirm that you're getting the same thing that I just got, right? Everybody there? Wait, I'm not hearing from anybody yet. Is anybody working? Okay, so Taj got that. Let's see, did anybody else get that? Okay, great. All right. And again, you're allowed to use your calculator. So by all means, if you have one of those that you can put the equation and just keep changing the number, that actually is perfect. F of 2 is next. And what are you getting for the f of 2? Let me hear from you now. I know what I have on my calculator. What are you getting for the f of 2? Alicia, okay, and Taj both saying the same thing, and I'm getting the same thing as well, -2. And we just keep going. It's as easy as what you see me doing here. I now have to find the f of -1. So I'm just going to press the calc button, -1. And okay, what's your answer, folks? Everybody else, what are you getting for -1? Come on, I don't want to have to call anybody out. Let me just get some reaction from the class here. When you put -1, just put -1 into the function, Taj and Alicia. Okay, Alicia has a different answer from Taj, though, and Anika has a different answer from Taj. So who is right, who is wrong? And Anika, okay, so Anika, Alicia, they all have a different answer, and Ashvan is agreeing with Taj on that one. What are other people getting? Do I have to call out names here? All I'm asking you to do, by the way, is just put a number into a function. That is it. Just be careful, though, when you're putting -1 in, just remember that things like, for instance, x cubed are going to become negative. Adam is saying a half as well. All right, my calculator is not giving me that answer, so maybe we should clear that up. Let me try mine again and make sure I did it right. Yes, my calculator is giving me what Sarah and Ariana are now saying, 2.5, 5/2. Okay. Yeah, you should check again. I mean, if you need some help with that, we can certainly look at that. And the last one is the f of 4. So go ahead, put that in your calculator as well, and let me know what you're getting. I know what I have. What are you getting? you forgot to put a minus. Yeah, that's kind of important, Fernando. We all make mistakes. I've certainly made my fair share, and it's a good thing that I have students like yourselves that will correct me when I make my mistakes. So Ashvan and Anika and Taj and Alicia or Fernando are all getting 20. There you go. So that's a nice easy one for us to get started on. Let's go back now and answer the question, right? Well, the question isn't actually stated, but it's asking us for the extremes of the function. So the extremes are what's the max, what's the min? Well, it's clear that the minimum value is the y value, is -2, which occurs at x equals 2. So it's actually one of the numbers that is within the boundaries, right? And the maximum value is 20 when x is equal to 4. So this one is actually on the boundary, right? See how easy that was, folks? I mean, obviously, this was an easy one, not just because the process and the steps are clearly laid out, but because you're dealing with a polynomial, which is very easy to differentiate. All right. So there you go. First one in the books, done. All right. We can move on. Folks, I need everybody getting their calculators out. Don't make me have to get that wheel now. I want to see a little bit more involvement. I know the Fernandes and the Tajas and the Ashvans and the Anikas are all ready to step up. Syra and Adam and all those people are all stepping up, but not everybody is, and that's not good. So please, without me having to get the wheel out, can we all sort of try to pitch in a little bit here? All right. So that's the first question done. All done. All right, very easy. And so we have a result, and I usually like to give where those results occurred. So you may put when x is equal to 2 or x is equal to 4. I like to put that in as well. All right. Okay. Let's try example number 2. Find the extreme for the following. Extrema means max and min. And they give you a function, and they want this to be between -2 to 4. So let me throw that out to the room. Behind that box, I have the derivative. Can you all spend 2 minutes coming up with the derivative in its simplest form for this function? Everybody. So let's see now. Let's see. This looks like it's going to be Tomaleo. Tomaleo, can you tell us what that derivative is, please? What derivative are you coming up with? Just Tomaleo, you have something for us? Okay, so C is supposed to be X. Oh, okay. All right. Let's compare that to what I have here. So you have -4x squared plus 16, which is kind of what I have. If you just sort of, excuse me, if you just sort of don't factor it out, and then you have the c squared plus 4 to the power c. Can you go over how to get it? Okay. All right. Let's just very quickly do that. So by the way, let me just say, Tamalea, good job. Remember that this is, you can either do quotient law or you can actually do product law as well, right? I don't know which one you're more comfortable with, but I'm going to go ahead with the quotient law. Quotient law says the following, Ariana. Are you saying okay? Meaning you're okay with it now, or you still want me to quickly go over it? Which one? Okay, yes means you're okay, you're good. Okay, perfect. All right. So we're now asking for where this thing is equal to 0, right? Remember, that's where you have your horizontal asymptotes, when the derivative is equal to 0. So I'm going to use the version that we had from Tomalea. What he has here is -4x squared plus 16. So -4, not 14. I'm not going to try to erase that, folks. That didn't go so well the last time. -4x squared plus 16 is equal to 0. So therefore, let's put the 4x squared and set it equal to 16. Right? That obviously should make sense. Alice account, I'm sorry, my screen froze and I couldn't use my function until I heard you calling my name. Okay, yeah, we're asking you for a derivative. So, okay, why don't you just solve this for us now, please? Minus 4x squared. Yeah, but it is minus 4x squared. But if I put this minus 4x squared item on the right, then it becomes positive 4x squared if I leave the 16 on the left. Or if I were to put the 16 on the left becomes minus, and then they're both minus. Okay. All right. So can you solve this for us, please? Tell us very quickly what the answer is for this question. Now that you're back with us, glad to see you're back with us. Can you solve this equation quickly for us, please? What's x equal to, if this is the case? Okay, it's actually plus and minus 2. Let's just remember that when you have to take a square root, as you would in this case, you're going to get two answers. Make sense, Koshi? That it is going to be plus and minus 2? Right, that's important because now we know we have actually two answers. So again, the steps involved, the 10 minutes that we have, now we know that there are two possible places where we have extrema, is to find the f of each of those. And for that, we're going back again to the original. Oh, by the way, you might be wondering what happened to the denominator when I was doing this. Remember that when you're trying to set something equal to 0, a rational function equal to 0, it's the numerator that counts, not the denominator. All right, it's just the numerator that counts. Just want to mention that. If there's an inequality, that's a different matter. But right now we're just talking about setting it equal to 0 and solving for x, and it works out to be plus and minus 2. So here we go. Let's now find the f of 2, the f of minus 2, and the only other thing that we have to find is f of 4. Because one of the answers that we got was the actual boundary itself. So it's the boundaries, right? The minus 2 and the 4, plus anything within that within this that we said was, a candidate, which is a plus and a minus 2. One of the things you also have to pay attention to are any of these numbers that we got outside of the boundary, because if they are, we can't use it. So far, they're not outside the boundary, so we're good. Okay, so here we go. I'm going to get my calculator to put that function in again. Here's our function, 4x over x squared plus 4. Actually, let's just do this together. F of 2. Is Jessica back with us now? Jessica, are you there with us? All right, couldn't find you earlier on. Are you with us now, Jessica? Is Jessica with us now? Jessica's still not with us. Okay, so f of 2 would be, remember, you're not putting it into the derivative. Let me just point that out again. We're putting it into the original function. So that's 4 times 2 divided by 2 squared plus 4. So for me, I'm getting 8 over, I guess that's 8, which is 1. Okay, so that's one answer. Oh, Ariana is saying 6. Did I do something wrong for that one, Ariana? I could have. 4 2 is 8. 4 plus 4 is 8. No. Oh, okay. Yeah. I think I'm okay. I think I got that too. That's all right. Okay. So the f of minus 2 now. See how simple this is? 4 times minus 2 over, excuse me, minus 2 squared plus 4. The top is minus 8, and the bottom is still 8. So that would be minus 1 this time. And finally, the f of the 4. I'm sure a lot of you are thinking that this must be the easiest part of calculus. It kind of is, to be honest with you, just following the steps. So I'm seeing 4 to 5 from Richard. Well, let me see if that's right. So it's 4 times minus 4. No, sorry, not minus 4. I'm not going to try that eraser again, folks. I'm kind of scared out of eraser now. So 4 times 4 over 4 squared plus 4. So I'm getting 16 over 20. That looks like, 0.8, 4 over 5. All right, which is approximately 0.8. So now we have our candidates. Let's just compare our values. We have a plus and minus 1, and we have a 0.8. So clearly, these two answers here would represent One is the max, one is the min. So the max is 1 at x equals 2, and the min is minus 1 at x equals minus 2. Okay, folks? All right. This is a nice, easy class for you to sail through. Okay, let's try to see if we can get one more in, problem 3. And similar question, but now we have a little bit more intense, more complicated looking formula to work with. The amount of light at a point is given by, and they give you a function where the time is in seconds. Determine the time of minimal intensity. So now we don't really even have to look for the maximum. We're looking for the minimum, time of minimum intensity. But the process is the same. We still have to go through finding the derivative, looking at it from the point of view of where is the horizontal tangent, or tangents, could be more than one, and could the minimum occur right at the boundary at 0 or 14, because that's where it could be. Okay, so let's go ahead and see if we can work through this in the 4 minutes that we have left. So the I dash t, or I guess that's I, would be equal to the root of the bottom, which the root of the top, which is 2t plus 2 multiplied by t plus 2. All right, just reminding you how this works. So the top is the 2t plus 2, bottom is t plus 2, minus, and I'm going to take the root of the bottom, which is 1, and the top would be the t squared plus 2t plus 16, all of that over t plus 2 squared. Okay, and we need to do a little bit of filing here. So let's see, that would be 2t squared plus 2t plus 4t plus 4, and we're minusing all these things here. So minus t squared minus 2t minus 16, right? All of the things in the brackets are being minused over t plus 2 all squared. Okay, let me see if I can quickly tidy this up now. So 2t squared minus t squared is just t squared. 2t plus 4t is 6t, minus 6t is plus 4t. All right, and 4 minus 16 is minus 12. Okay, all right, so we need to get this thing to be equal to 0, but we need to factor it first. And in the quick time that we have here, I'm thinking t plus 4, t minus 2. No, that's wrong. That's wrong. That's not 4. I'm really afraid to touch that thing, x plus 6. All right. Anyway, so hopefully you all agree with me on that. X plus 6, x minus 2. So that means that t is equal to minus 6 and 2. But guess what? We can't bother. There's no point in testing minus 6. Why is there no point in testing minus 6? Quickly answer that question for me. Anybody? Why is there no point in testing minus 6? The time? Yeah, in fact, it's time, right? And also because they gave us a domain of 0 to 14. Right? They gave us a domain and said it's outside the domain. That's exactly right. It's not in the domain. So Ashra and Sarah and Adam and Tomala, they're all correct. And so we're not even going to bother to test minus 6. We're only going to test the 2. So very quickly, we have to test the 2, we have to test the 0, and we have to test the 14. So in the 1 minute seconds that we have left, we're going to have to find, and you can finish this up, find the f of 0. You have to find the f of 2, and you have to find the f of 14, right? And some of these are quicker than others. I know I can do 0 easily. 0, just looking back at the function here, that's going to make everything disappear except the 16 over 2. So the f of 0 is 8. All right. The f of 2, how quickly can we do that now? So that's 2 squared, that's 4 plus 4 plus 16 divided by 4. That would be 24 over 4, which is 6. Am I right? F of 2 is 6. And then the f of 14, I remember looking for the minimum value, So the f of 14 now, oh geez, that's going to take a little time. Anybody have the f of 14 quickly so that we can, 15 is what Carly says, and okay, 240 was 16, 15, okay. Thank you. F of 14 is 15. All right, I'm going to take that word, the word for it. So the question is, well, what's the answer then? Right? Remember, we're not looking for the maximum, we're looking for the minimum. So obviously, this is the answer that we're looking for. F of 2 is equal to 6. That's the minimum intensity. And that's it. That's all. We're done. 12:35. Folks, thank you very much. Please remember to turn your homework in. And I will see you tomorrow. Have a good lunch now. See you later. Bye.